Hello and welcome to this 4IT techELITE session looking at artificial intelligence and machine learning on AWS. This is the third of our series of 3 technical webinars hosted with Amazon Web Services and will be presented by 2 AWS solution architects, Emilia Brzozowska and Ozioma Ozegu. So this evening we will enjoy a presentation from Ozioma, followed by an on-screen demonstration by Emilia. They will both, no doubt, generate questions, which I would ask you to note in the chat function of your GoToWebinar control panel, and we will spend the final portion of the session looking at as many of these as we have time for, before closing at 7:15. I'll hand over the screen now and ask our speakers to introduce themselves, Emilia and Ozioma.
Hello, good evening, everyone. My name is Ozioma Ozegu. I'm a solutions architect in AWS, and I'm here with my colleague, Emilia. Emilia, do you want to introduce yourself?
Hi, everyone. My name is Emilia, solution architect, working in the same team as Ozzy.
Cool. Thank you so much, Emilia. Can you see my screen now?
That's great, Ozzy, yes.
Cool. Good evening, everyone, once again. We are going to be talking about giving an overview of AI and machine learning on AWS. We'll cover quite a bit of content, and like John mentioned, Emilia will be doing a quick demo at towards the end of the session. So feel free to ask questions as well on the chat as we go along. Okay. What we've seen at AWS is that businesses of every shape and size is collecting quite a lot of data on a regular basis. This can be customer data or data from devices. And this really begs the question, how can you get more value from your data you're collecting? And that's really where a data strategy comes into the picture. It's all about how can you as a business build a foundation for transformation and innovation. And we believe that the 2 technologies that will power that are things around data analytics, which we heard a lot about in the last session last week, and machine learning. We've also seen customers moving towards what we call a data-driven organization. But what does that really mean? It means 3 key things. So the first is that data is now an organizational asset. What that means is that data is no longer kept in silos or the property of any individual department. It's treated as a company asset and is used by everyone. For example, data from the customer service team can be combined with data from the order and fulfillment team to form a single big data source that can be used organizational-wide. Second is that data is democratized. What that really means is that data is available and can be easily and securely accessed by anyone that needs it. So whether it's for reporting or for business intelligence or for analytics or for machine learning, is available and democratized. Finally, data is put to work, and this is where it begins to get interesting. So how can you then apply analytics to the data you've gathered? How can you start looking at concepts of machine learning? And the aim of all this is to really try to create efficiencies in your business or to drive new innovation or introduce new products. But what are the paths that we see customers going through to be able to become a data-driven organization? The first is really modernizing your data infrastructure. And this is really around moving off old on-premises data infrastructure. Again, the idea here is that not every use case will require a SQL relational database. Depending on your workload and the type of application you're running, there are data stores that are more suited for those databases, for those applications. For example, if you're running time stream application, or if you're running graph related applications that need a graph data store, the first step is about modernizing your data infrastructure and make sure that you're using the right tool for the job. The second is around liberating your data. And this is really around how can you start building what we call a data lake. Ahmed covered this extensively on the session last week. And also lakehouse architecture. And how can you basically liberate that data, build a single data lake, and allow anyone within the business that needs access or permission to that data to be able to be granted. Of course, with implementing security best practices and principles as well. But finally, then it comes to how can you innovate with ML? This is really where you begin to put data to work for you, start getting intelligence out of your data, and that will really be our focus for our discussion today. Before I delve into machine learning, I want to kind of do some level setting in terms of what is really artificial intelligence. What is this all about? We describe AI as a way, as basically any system that is able to replicate the task that is previously required human intelligence. I mean, for example, imagine the Alexa you might have at home. That kind of, you can query with natural language, it understands your language and be able to kind of process that language. We have another concept as well around machine learning. And what is machine learning? It's a subset of AI that basically gathers large amounts of data and be able to find patterns in that data. And the idea is to be able to carry out logic, so carry out decision logic similar to what we do as humans, and also be able to kind of make predictions at scale, which we'll cover in a lot more detail in the following slides. Another big term that we'll be using is around deep learning. And what is deep learning? Again, it's a subset of machine learning, but this is really using the technology we call deep neural networks. And these systems basically replicate the way the human brains function. So if you think about systems or machine learning systems today that kind of help in performing complex use cases like things like speech recognition and image recognition, that's the realm of deep learning. What we've also seen at AWS, and also what the analysts have also put forward, is that ML is growing. Originally, this was used to be a technology that is only accessible to big corporations with large capital expenditure to be able to buy the physical infrastructure and also invest in the human capital to be able to build machine learning models. But we've seen that growing over the past couple of years. In fact, IDC predicts that by 2024, that the global spending of artificial intelligence will reach $110 billion. We've also seen customers moving from piloting to actually operationalizing machine learning, and 75% of enterprise will shift from piloting to operationalizing AI by 2024, and this is according to Gartner. And transformation has really been the key aim why customers are adopting AI. And Deloitte forecast that by 57% of the organizations that they interviewed around how AI is driving transformation believe that that will be the key pillar to transform their business in the next 3 years. So these are technologies that have come to stay, and we've seen businesses and customers adopting ML, and it's growing year on year. Within AWS, we've actually seen customers adopting AI and ML at scale to solve business problems. For example, Intuit, who used AI and machine learning to be able to build a forecasting system that will be able to predict the customer demand and also match that with the customer call agent that is required in their contact center. So they had a problem in terms of being able to meet the demand of the calls coming in their contact center versus the resources they need to be able to attend to those calls. And they used AWS forecasting services to be able to achieve that. Convoy is also another business. It is actually a Seattle-based logistics company. And what they do is actually they do shipping, but they have transformed the way they do that using AI and machine learning. They've basically built what they call a convoy matching system that will be able to match shippers with trackers and be able to deliver these goods at a very cheap rate and also make sure it's done quickly. And they've been able to achieve that with AI and ML. Sena is also another company we've worked with. They are in the health information technology space, and health is quite important to everyone. And they have really taken a step back to really think about how can they transform healthcare and streamline operations within the healthcare with AI and machine learning. And they've gone ahead and built a model that can actually predict a congestive heart failure, which is a very chronic condition, that can be able to kind of display the symptoms of those of of any congestive heart failure 15 months before it actually happens. Think about the savings that this could have for patients and for people suffering from that heart condition. And finally, NFL. We've worked closely with NFL for over the years, and we've worked with them to build what we call next-gen stats. So imagine players that go to watch, or fans that go to watch NFL, both in the field, or fans that are watching remotely or virtually, and even partners that partner with NFL to kind of stream their sports all over the world. NFL was looking for ways to innovate the way they engage with their fans through statistics and really bringing to life what is actually happening in the pitch. And they worked with us closely to build what we call the 20 unique next-gen stats. And for example, one of them can be if you want to model what is the expected yards after a catch that a player will go. So imagine you throw a ball and the player catches it. To be able to kind of bring out the stats or the predictions of how far that player will fall after that catch is an interesting application where AI and ML has been applied to kind of use the player conditions, use the speed of the player to be able to bring these stats to life to fans all over the world. Within AWS, we've also used machine learning at scale. We've been using machine learning for over 20 years now of running Amazon.com. In fact, when you go to Amazon.com, the recommendation systems you see there are all based on machine learning. And we've been able to, it's one of the contributing factors that have helped us to be able to sell 4,000 products per minute on Amazon.com. And then when it comes to our fulfillment center, being able to predict the global demand of any product we sell all around the globe and be able to kind of determine the best route to ship that product at the right price point and as fast as customers want it. We really use machine learning to be able to help us with that forecasting and be able to meet customer demand. We've also developed natural language processing technologies. I know some of you have Alexas at home, but this has really transformed the way consumers interact with technology. And this is all powered through machine learning. And finally, when it comes to kind of delivery, we're also kind of innovating in that area. And we've built the autonomous flight via Prime Air drone. And a lot of robotics we also use in our fulfillment center to be able to package goods to consumers as quickly as possible. So we've been using AI and ML at scale within Amazon. And what we're doing is to really share that learning with our customers by building new products that will help customers to eliminate the heavy lifting that involved in building machine learning or using machine learning within their business. We've also done this for a number of customers from both startups to enterprises. They've all kind of embraced ML, some of our ML services. People like Babylon, for example, that is into the health space, right up to Kia, big enterprises, as well have been using machine learning on the platform. But I think the key question is, why are customers choosing AWS? Apart from our experience in running machine learning and applying machine learning within our business, what are other reasons why customers come to us or come to the AWS cloud for machine learning? I think the first key point is really the broadest and deepest set of our AI services. Over the last year alone, we launched over 200 plus new features, and we've got solutions across the spectrum, from solutions that application developers can use with little or no experience to solutions for ML experts or data scientists to build machine learning in the platform. One of our technologies, or one of the services we've built that have helped us to really do that, is called Amazon SageMaker. And customers have accelerated their ML journey with Amazon SageMaker. It's a single ID that you could use for your entire ML workflow, from data preparation to deploying and running inference on your machine learning model. And that has really helped customers to save in terms of total cost of ownership. And some of the functionalities we've provided in SageMaker, like using spot instances, can help customers reduce 90% of the cost of training within SageMaker. And finally, again, the AWS cloud have got quite a lot of services. Is the most comprehensive cloud platform in terms of security, reliability, our featured data store, S3, which we'll be talking about a bit more during the demo, and also a range of services from compute storage and security that can help customers to really build machine learning models on AWS. Okay, So we've talked a little bit about kind of why AWS and some of what customers are doing and some of the customers we have on the platform. Let's then delve into what is this machine learning and the services we have on the platform. First, but before I do that, I'll go back to just to help to set the scene. What is an example of an ML problem? I've talked about ML quite a bit, but I want to kind of bring it to home and so that we can really see an example of a problem that ML can solve. So the example I've got is being able to predict the price of a house. So imagine you want to predict the house of a price, the price of a house, say maybe the price in London or in Manchester or wherever you live. As a human, if you know the house size or the floor plan, whether it's a 2-bed house or 3-bed house, or you know the floor plan, or you know the location where it is, whether it's in central London or center of Manchester, you'll be able to make some intelligent guess about kind of what the price will be. And that is great. But what if you start thinking about other parameters that kind of affect the price of a house? Things like whether it's a fully detached house or a semi-detached house or a bungalow, for example, or what are the kind of regulations around the area that might potentially affect the house price? What is the proximity to social services or to transport links or to schools? All these affect the price of a house, and expecting a human to be able to gather all that information and be able to make predictions of what the price of a house is going to be a big ask. And also imagine if you had to expect a human to do that at scale, to do that for not just London and Manchester, but the whole of the UK and potentially above that as well. So that is really where machine learning comes into play. So the idea is to basically gather the data of all the features that potentially can affect the price of a house, gather that data and build that intelligence into a system, and that would then be able to kind of spit out the house of a price based on the features or the parameters of the house. So the idea is you build this system, you gather all the data, build that intelligence into the system, and then you'll be able to kind of ask the system, for this house with this XYZ feature, what will be the potential price? And it will be able to spit that out for you. And then you can also do this at scale, which means that it will be able to respond to you quickly as against maybe what a human will need to do, spend time and do all the calculation. It will be able to kind of do that quickly and also do that for you at scale. And that's really what machine learning is all about, being able to build that intelligence into a system to help us to be able to make predictions at scale and also very fast. So what does that process look like? If you are to kind of build a model that potentially can predict the price of a house, there are steps that needs to be you need to go through to be able to do that. The first part is about collecting the raw data. So you need to gather the raw data, do a lot of data preparation, and this is about kind of looking at the data, doing some hot encoding, things like hot encoding, removing missing values, identifying features that are really important, doing things like feature engineering, and getting the data to a point that it will be ready to be able for you to build your model. And from what we've seen, 80% of our machine learning model, kind of 80% of the time you take to do machine learning actually fall within this area. And then you go over to build. This is where you kind of pick the framework and the computer algorithm you want to use for your machine learning. And then most people kind of use the Jupyter notebook using Python to kind of build the model, leveraging the data and applying the algorithm on the data. And after that, you leave the model to train. You train the model, and this involves kind of using compute to train the model over time. It can take between minutes, hours to days. And then when the model is trained as well, or as part of the training, you also kind of apply hyperparameters to tune the model, see what the outputs you are getting, and tune the model with hyperparameters to improve the prediction or to improve the accuracy of the prediction. And finally, you deploy your model. So this is a case of basically providing the model as an endpoint where people can query the model to get inferences or to get inferences. But again, this process is not that easy, is not straightforward, it's not always kind of from point A to point B. It involves a lot of kind of iterative processes, either within the data preparation and building, because sometimes you find out that the data needs some more processing, you have to go back, or you need to do more tuning or apply different hyperparameters to tune the model a bit more. It's an iterative process that has to go on over time before you get the model you are comfortable with in terms of accuracy. And when new data comes in, or when you get new insights, you can also bring that in that iterative process to go through these steps again. So as you can see, the machine learning development process is not that easy or straightforward. It's complex, and it's also costly when it comes to the infrastructure you need to do these activities on. But our mission at AWS is to really make this easy and remove the undifferentiated heavy lifting that comes with those four-step process, and put machine learning in the hands of every developer and data scientist. The way we do that is with what we call our technology stack. We believe that customers today that might be running on-premise, or customers that might be in the cloud, we have built a technology stack that will be able to help you bring your data and apply machine learning, build machine learning models, or use our AI services. So this is what that stack looks like. So this is the full AWS machine learning stack. There are three layers of the stack, starting from the AI services to the ML services and framework and infrastructure. And I'll be going through each of them one after the other. But the thing to mention there is that what we've tried to do here is to provide services that will be able to help you achieve any specific business outcomes, and also to help you to be able to meet your needs. So irrespective of your knowledge in machine learning and where you are in your expertise in terms of machine learning, there is always something for you to help you to apply AI or machine learning in your application or also in your workplace. Each of the stack are applicable to a wide range of use cases and industries. So irrespective of whether you are in media and entertainment, or whether you are in manufacturing, or whether you are in IT services, you can use any of these layers in terms of implementing AI and machine learning in your application. But over the years, we've gotten feedback from our customers, and we've started also building bespoke industry solutions, like in industrial AI services, like your Panorama or Monitron, or when it also comes to health as well. But let's start with the top of the layer, which is the AI services. Like I mentioned, what the AI services are basically a pre-trained models that provide ready-made intelligence for your application. So you don't need to build go through that four-step process I went through initially. We've all kind of packaged, built a model, and build that intelligence into a model, and expose this as an endpoint that you can access either via AWS console, or you can query via an API. So imagine today you have an e-commerce company that takes credit card payments. You can use a service, for example, Amazon Fraud Detector, to be able to detect any fraud, credit card fraud going on your platform. Or if you want to implement enterprise search within your business, we have an AI service called Amazon Kendra that could help you to do that. If you want to implement chatbots, we've got Amazon Lex that could help you to do that. If you want to kind of start looking at anomalies within your metrics, so for example, you have revenue data, you have sales data, you have clickstream data, and you want to start identifying potential anomalies within that data in an automated fashion using AI and machine learning, you've got Amazon Lookout for Metrics to help you to do that. I will take you through a couple of examples of these AI services and what they do. I'll pick Amazon Comprehend. So what is this? It's basically an AI service that helps you to discover insights and relationships in your text. So if you've got text maybe from an email, from a chat, or from a phone call, or from messages, Amazon Comprehend will be able to kind of consume that text and be able to discover insights and relationships within that text. For example, it will be able to detect entities, key phrases, sentiments, whether it's a positive sentiment or a negative sentiment, PII information, and it also allows you to kind of bring your own custom entities, to train Comprehend with your own custom entities. Imagine if you're in a particular field where you have a particular set of entities that matter, or that is unique to that field, you can train comprehend to be able to recognize those entities in any text you pass into it. So this is an example of entity detection in comprehend. You can see on the left the text that was passed to comprehend, and these are kind of the detection or the entity detection that comprehend kind of made from this text. So you could see, you could say that Seattle is a location, that thousands of customers is a quantity, and event is actually an event. When it comes to PII detection, this is quite important for a lot of customers in terms of making sure they meet their regulations. Amazon Comprehend will be able to kind of detect things like someone's name, SSN number, address, and phone details, and also email address. And you can use this to be able to maybe hide those information before you pass that text to the next layer of your application, or before you expose that data somewhere else. Another AI service that we have is called Amazon Forecast. If you think about forecasting, it's kind of is used in a lot of businesses, from inventory planning to workforce planning to capacity planning to financial planning. It's quite an important tool that businesses use to be able to match demand supply. And what we've built is called Amazon Forecast, and it's an accurate time series forecasting service, and it's based on the same technology that we used at Amazon.com, and no machine learning experience is required to be able to use it. So how it works is that you feed in your own data. So if you've got data about the demand of your particular product, the historical data, you could feed that in, whether it's sales or inventory or call volume, and then you pass in the related data like the prices, or whether there was a promotion, the weather conditions during that, and some metadata as well. Amazon Forecast will take that data and go through the full end-to-end process of machine learning and be able to expose a customized forecasting API that you can use to kind of do forecasting for your business. So this is really a game changer when it comes to forecasting. You don't need to know any machine learning to be able to use it. Give it the data, it gives you an endpoint so you can forecast for the future. Another AI service we have is Amazon Recognition. These are our deep learning-based image and video analysis AI service. So you can see on the screen, you've got the gentleman cycling in a rocky path, and you can see it's able to kind of give you details or detect kind of entities within that image. You can see the person, the rock, the mountain bike, is able to kind of detect some of these items within the scene. And it gives you a level of confidence in terms of that detection. For example, for the person is given a confidence of 99.3%. In fact, I've also tried this out as well. So this is a lovely dog image that I just basically called with recognition APIs. You could see the request. The request API is basically just an image. You pass the image as a request, and the response, it gives you quite a lot of detail about that picture. It tells you that there is a helmet there, the pencil is the type of the dog. It tells you that the dog, there's some clothing going on there, that the dog is wearing some clothing. And it gives you details potentially of the location of these items in the picture as well. So it's quite a powerful service that you could use to start detecting things within an image. And you can also train recognition with what we call custom labeling, where you can bring your own image and label the image, and recognition will be able to kind of make predictions based on that. The second layer of the ML stack is what we call SageMaker. And SageMaker basically provides every developer and data scientist the ability to be able to build, train, and deploy machine learning models at scale. So our aim when we build SageMaker is to be able to remove all the complexities that is involved in building machine learning workflows and really make it easy for customers to be able to use machine learning. So if none of our AI services will be able to kind of suit your use case, you have the flexibility of using SageMaker to build your own custom model. But what we've done is to make it a lot easier for you by removing all the undifferentiated heavy lifting. For example, if you look at things like custom labeling data, we have SageMaker Granted that could help you to do that, from tuning parameters to building CI/CD pipeline to implementing things like feature stores. we've integrated that into the service to be able to help you, make it easy for you to be able to build machine learning model. These are all done in what we call the SageMaker Studio. I've got a screen of the SageMaker Studio on the slide, and Emilia will be delving deep into that as well. But it's basically an IDE where you could do all the end-to-end machine learning process, from data preparation to running experiments and also to implementing pipelines. The key point to mention there is it's also a managed infrastructure. So you don't need to worry about the underlying infrastructure that is running your model, or you're building or training your model on. It's all managed for you. And we also kind of implement things like auto-scaling and distributed trainings to be able to help you to run machine learning models at scale. We've also built in tools as well. So if you think about things like being able to identify bias within your machine learning model with SageMaker Clarify, and things like for debugging your model or monitoring your model, we've built all this tooling within the service that you can easily use without having to build some of this tooling from scratch or build it yourself. One of the features that we'll be also demoing during the demo section is called SageMaker Autopilot. And I think this is really where it begins to make a lot of difference. So this is an automated machine learning component of SageMaker, where you bring your data and SageMaker will do the work for you in terms of preparing your data, building the machine learning model, training and tuning the model, and giving you a model endpoint to be able to make predictions. It's suitable for regression problems or where you have kind of binary classification problems or multi-classification problems. That is what is suitable for. For example, you've got data, it can be direct marketing data, where you basically store this data in S3, and then you have a column you want to predict. So imagine the column on target is like our column we want to predict. So this is like a binary classification where it can be 0 or 1. And that's the column you want to predict. What you just do is to push this data into S3, link that, specify the URL to S3 within Autopilot, and then tell Autopilot this is the column you want to predict, and Autopilot will do the rest for you and give you a set of models or a set of experiments in a leaderboard fashion, showing the accuracy of each of those models. And you can then make a decision which one you want to take and which one you want to leave. And it also gives you all the underlying SageMaker notebooks that was used to build that. So it's not a black box solution. You can leverage the notebooks that was used to actually do the data preparation and the training and tuning of the model, and you can modify this to your taste or make any changes to be able to enhance your model a lot faster, a lot further. SageMaker also has other features. Like I said, it provides functionalities across the full end-to-end ML process. For example, in the prepare stage, you can use SageMaker ground truth for labeling of data. We've also recently released, as part of reInvent 2020, what we call SageMaker Data Wrangler. This actually changes the experience for customers when it comes to data preparation. This is a very difficult and tedious aspect of machine learning, but we've built a GUI for customers to be able to prepare their data, apply all sorts of transforms, and be able to kind of see the journey the data transformation is going through as part of data preparation. We've also got, when it comes to building, we've got SageMaker Studio notebooks. These are basically Jupyter notebooks that you know and love, but you don't need to worry about the underlying infrastructure. And we've also kind of allow customers to either bring your own algorithm or use one of the built-in SageMaker's algorithm. When it comes to training, we give customers a lot of functionalities when it comes to training and tuning. We enable customers to do automatic model tuning, run different experiments, and you'll be able to kind of see all the details about the experiment in terms of the input data and the tuning data, so that you can compare different experiments and understand the differences between the experiments. We've also enabled customers to do spot training, which uses our EC2 spot rate and can save customers up to 90% of of the cost of training machine learning model. When it comes to deploying, we've also got various ways customers can deploy and host their model on SageMaker. We have the SageMaker hosting, which provides the managed hosting for your machine learning model. We've also recently introduced what we call SageMaker pipelines, and this helps to kind of implement the similar concept like CI/CD and DevOps into your machine learning process, where you can build a full end-to-end pipeline to automate the process of preparing, building, and training and tuning and deploying your model, and also ingesting new data to be able to enhance your model and release a new version of your model. But the important thing to also mention is that SageMaker is not an all-in solution. We allow customers to use any of these components you want to use as part of your machine learning, depending on your use case. So for example, some customers train their model on premises or train their model somewhere else, and they want to kind of use SageMaker for the hosting. You can bring in your container, or you can bring in your model into SageMaker, and we can host it on SageMaker, and you can use SageMaker only for hosting. And we've innovated a lot in terms of how we enable customers to host on SageMaker. And with the release we even just done only last week, where we now allow you to kind of deploy multiple containers in a single endpoint for your inferencing. So finally, at the bottom of the layer, we've got the frameworks and infrastructure. So this is really for expert practitioners in machine learning that want to kind of develop on the framework of their choice. So if you imagine the popular frameworks like TensorFlow, MXNext, and PyTorch, some customers want to actually do this themselves and not use a managed infrastructure. And we provide that capability as well. And what we do is that we provide deep learning AMIs and containers that customers can easily use to be able to get going with building their own machine learning models. Over the years, we've also kind of innovated in the area of chips. So we've released what we call Trainium, which is a chip that you could use for machine learning training, helps you achieve better price to performance ratio, and also Inferentia, which also helps with inferencing. Inferencing is a key aspect of the infrastructure required for machine learning, because once you build a model and deploy the model, the next thing is receiving requests for inferencing, which consumes quite a bit of resources. So Inferentia is a way of helping customers to build or to use AWS to deploy their model and achieve lower price to performance ratio when it comes to inferencing for your machine learning models. So just to also give a little bit, delve a bit deep into kind of infrastructure. I know this is what has really made it a bit difficult for customers to leverage machine learning technologies over the years, but the cloud has kind of helped to democratize this and make this easily accessible for everyone. When it comes to the cost of infrastructure, it's actually majority of the cost of the infrastructure is all around inferencing. Training takes quite a bit, but majority is around inferencing. And we are innovating in these areas, and we are building AWS custom chips, like I mentioned in the last slide, to help you to be able to reduce some of these costs and be able to innovate and leverage machine learning technologies. One of the releases we did recently was the introduction of Amazon EC2 B4D instances, and this helps customers deliver highest performance for machine learning and also high performance computing. It's built with NVIDIA, the latest NVIDIA A100 GPUs, and we've seen customers use these for high performance computing and also in training their machine learning model. And without further ado, I will hand over to Emilia to kind of take us through a high-level demo of really these AI services and some of our machine learning technologies as well. Emilia, over to you.
Thanks a lot, Ozzy. Just one second. Great. So being cautious of time, I'll do a very quick intro to what are those two services I'm going to present. So one of them is Lookout for Vision. That's the part of the AI stack that Ozzy talked about. So the managed services where you don't need to really know anything about the ML, and we give you this package solution for your business problem. And the other one is the SageMaker Autopilot, which is more for ML enthusiasts. But still, I want to show you that it's very simple, and I actually don't need any knowledge as well. But you have ability to look into the process, what SageMaker is doing behind the scenes, what are the steps are taken. You can even see the snippets of the code, what exactly was happening. While within the AI services, you can't really look inside the box. So quickly for the slides. So what is Lookout for Vision and what problem it solves? Basically, it's for quality prediction. So when we have a product that we are manufacturing, or there is a manufacturing line with some product we're trying to sell to customers, we want to make sure this product has no defects. And so as the sentence summarizes very well, it's about spotting product defects using computer vision and making it more automatic. So we don't need to have someone checking the product. If there is like a scratch on the glass, we can have a camera sitting on top of the manufacturing line and flagging it automatically for us. And so I'm gonna use the circuit board. Oops, sorry, it's the office light. Apologies. Excuse me. So we got this is our data set. It's going to be 40 pictures of circuit boards, and 20 of them are with anomalies, 20 of them are without. So here on the screen you can see only top right is actually without anomalies, so we can say it's the one we want to have, and all the other three have something. So the one on the bottom right has like a soldering defect. Bottom left, similar thing, soldering here, close the white piece, and then here are some scratches. So that's something we want to flag that, okay, this is anomaly, we don't want to send it to the customer. Okay, let's jump into the console. I'll be running very quickly, but you will get the recording afterwards, so you'll be able to rewatch it if needed. So log into AWS console and search for Lookout for Vision. Now, if you're doing it the first time, you will need to go for the Get Started splash screen, which basically Lookout for Vision will ask you for permission to create a bucket to use for output and input objects into the S3 bucket for you. I did it beforehand, so I don't need to go for that process. I can go straight into the projects, and we're going to create a new project. They had a couple before as I was testing that. Let's use demo. Click create the project, and that's it. And now we can create our data set. So very simple. We don't need to have any ML knowledge. Just click create a data set. We can choose to create a single data set or training and the test data sets. I'm going to go with the single, but it's not a critical move. You can change it afterwards, so don't worry. Or we can choose out of 3 options. So you can store your data set either in the S3 bucket, or you can upload messages from your PC or from the ground truth. You were using ground truth before to label your data. For me, it was comfortable to use it in S3. So I will go to my S3 console where I already uploaded my data sets. And I'm going to copy the S3 bucket URI. And you can see already within the structure, I created like 2 folders called anomaly and normal. And in each of those folders, I already grouped. So I know where are my pictures with circuit boards that are correct and the ones that have anomalies. So I can use this structure. And I'm going to paste the bucket in here. And because of this structure that was recommended as well, I can already automatically attach labels. So this saves us, some work, and it will be automatically labeled for us. So create dataset. It'll take a couple of seconds. While waiting for the images to load, bear in mind it's a very small data set. 40 pictures is very, very little. So we have to be understanding of the model. But of course, if it's production, you would have way more pictures, and also on the fly, you would take more and more and update the model, rebuild, retrain. Great. So we have 40 images. They're all labeled. This is exactly what we wanted. And we can see them here, anomalies. Already labeled, normal, anomalies. Great. And all we do is click train model. Train model and train model. And that's it. Our model is working on the background. So say part of the service is currently launching infrastructure behind the scenes to use the model trained with the pictures we provided. And it will take a couple seconds, so a couple minutes. So I'm not gonna waste this time here. So I already deployed this model before, so we can quickly jump to the screen. What would happen if this one was already finished? So let me jump to a different project. Say demo 2. They're all the same, just lots of demos doing demos. Great, and we can see the model, and it says the same screen, training complete. We have already some precision prediction, and we can check that, right? So let's do the trial. Let's try this model. I'm gonna run trial. I hope the light won't go off again. And we're gonna call it trial, no, maybe 10 in case it's already existing. And this time, actually, I'm gonna upload the images from my PC to show a different option. So I'm gonna click detect anomalies, run trial detection, choose file. And I am in the PC folder when I already have like my test images that I didn't use before. This is like completely separate set to see if the model is actually marking correctly, labeling correctly what I want, what I think it's normal circuit board or with anomalies. So I'm going to choose just one image for now because to speed it up. It's uploaded. It will take again a couple of seconds. Great. And now we can see the threat detection task started successfully, and it's in the process. So the task is running. So when we go in the trial detection, we can see this is happening. This is running. And what's happening behind the scenes is that the model is not hosted anywhere. So to make the trial detection, the service needs to provision infrastructure behind the scenes, then run the model against run the picture against the model, and then return the information. I'm gonna use the one I started before, so it saves some time and we don't have to wait. So let's pick trial 3. Oh, and this one is actually wrong. So we can see that it shows anomaly, but it's actually normal. And in that case, we can correct our model. So we can click on that. Excuse me. We can click on the top, verify machine predictions, and say this is incorrect. This should be anomaly. It's called test anomaly. I can't say anomaly myself, but for sure there is. And we can click incorrect, and then we can click add verify images dataset and retrain our model. So mistakes like this happen, of course, because of the small data set. But once you run more and more, and we have more images, bigger data set, of course, it will be improved. We can also need to give it a second as it's saving changes in the data set. Great. We can also check the model precision. So actually, we were very unlucky to get that response, as it should in 76% it should work. And then once you're ready and you think your model gives enough good results, you can deploy that model, and you have already like prepared for you commands for the AWS CLI. You just copy and paste, and you can start using that. So you have to start your model. Once it's running, it will be running until you stop it, and you can call the endpoint to predict the new images. Okay, it's time is all right. So now quickly back to the slides, and we'll focus now on the autopilot. So you remember when Ozzy was talking about this process that takes actually quite a lot of time and it's complex. When you get from the raw data to deployment, there is lots of data work preparation, tuning hyperparameters, so on. So this is the part that autopilot will take care for you behind the scenes. You don't do anything. You put the data, you get out a list of models in the fashion of the leaderboard, and it even gives you like what is the actually top performing model for you, and you can just go and deploy it. The difference is that this is not a black box. You can go and see exactly what's happening behind the scenes. You can even see the Python scripts, exactly the commands that will run, and they're also executable, so you can actually run them. And now let's look at the data set we have. So this is like a banking marketing data set where we have information about our users. And we're looking at different information like age, marital status, job, the education, some other information. And what interesting, if this marketing campaign actually worked for that customer, and they bought the service or they used the service that we're recommending to them in this campaign. So this is the yes/no information we'll be looking at. We want to know. We want to build a model that will be able to predict that information based on the new customer that will join. And yeah, we can clarify if this campaign actually will work or not. If not, there's no point maybe spamming the customer. Great, so back to the console. I know I'm running quickly for the demo, so we are in time for some questions. So again, let's go back into the management console. Once you are logged in, you search for SageMaker. Some time. Second. My laptop froze and I can't see the pointer. Okay, got the pointer back. Sorry, it's a bad day for my laptop. Once you are in the SageMaker splash screen, click on the SageMaker Studio. And you will open the SageMaker notebook. So if you don't know how to get to that step, because it requires like some job before, it's basically once you open the SageMaker, it will ask you to create a user, and that's it. And I'll also share the link after the session, so we can do step by step how to create that user and have that notebook ready for you to use. So right now I'm going to just click that, and again, to save time, I'm not going to wait for that to load. We got the Jupyter notebook already open. And yeah, great. So we're here. This is the ID Ozzy was talking about. This is the one that was on the slide. This is where all the SageMaker features are available for you. But we're going to use just autopilot, so it's very simple for us. So first, you search for this palette here and search for experiment. Click on that. We're going to give it a name. Experiment. And now we'll give it a S3 bucket where our data is. That's all we need to actually give. The data set, the URI for our data in S3 bucket. And you can connect also different resources. It doesn't need to be S3 bucket itself, but if the use case for tabular data. So if you have like an Excel with data or CSV file or database, this is where you can use the autopilot. Forgot to mention before. So I'm gonna copy that. Go back to my Jupyter, place it here. Okay, input, great. And now the important one is the target. So yeah, as you remember in the table I showed before with the data set, the Y column is the one that is of our interest. This is the one we want to predict and know if it's correct. So we're gonna just type now Y as the column that is for us. We want to find about this one, and then we need to also give the output bucket. So I'm going to use actually the same one, but instead of input, I'm going to put output at the end. Output. Great. And now, what is the problem we have? So is it binary problem? Is it regression? So regression would be the example that Ozzy shared with predicting the price of the house. But we have the binary problem. But it doesn't matter. You might not need to know that at the moment. We just put auto, and let's see if autopilot should discover in itself how it works. So I'm going to create experiment. And this is the pipeline we're talking about. So this is where all the job is happening. Behind the scenes, we have the pre-processing happening, the tuning, all the job is happening behind the scenes, but you have access to that. So once that is over, and I have, of course, deployed before, so we don't have to wait, it will take like 20 minutes. Once that is over, we'll have notebooks available to us to run for those steps. So let me show you this pre-processing has already started. Let me see how it looks like. Let me show you how it looks like once this one is over. It will look like this. So we will have the leaderboard of all the models available to us to use, and there is the best one with the highest, precision, F1 ratios, precision accuracy ratio. So we would deploy this one, right? It's the best one. And those are those notebooks I was telling you about. So this is how you can see how our data was discovered, what was discovered when in this phase, and what were the steps that SageMaker Autopilot took to get those models in that format we have here. So let's first go for data discovery. And this notebook basically tells us all the information that it found out about the data. We're running very late of time, so I'll probably stop here. But once that is completed, you click deploy. You literally give the name of the endpoint. Let's say new endpoint. Deploy model, and it will take some time again. And the last thing I want to show you before I hand over to Ozzy and John is once this endpoint is ready, you can use the test data to see what was the precision of that, and there are like ready prepared scripts as well for you. I will share the link step by step. Okay, excuse me, it was very short time for me to go for 2 demos. I hope it was a little bit useful. And Ozzy, over to you for last 2 minutes.
Cool. Just a minute, let me get this going. Cool, thank you so much for that, Emilia. And in terms of, I know the question is, where do I start? If you want to kind of start looking at machine learning on AWS, and we have, for businesses, we have kind of ways we can get you on that journey, and also for individuals, we have training, proof of concept, and then you can start looking at moving to production. Some of the things we have in terms of building your skill, we have the Deep Racer League. This is all about reinforcement learning, which is an interesting area of machine learning, to be fair. But we've gamified that in a way, and also built a competition around it. So John will be sending the link after the session in what is involved to be able to join if you're interested. And also we have a lot of courses as well. I'll be sending a lot of links as well through John in terms of machine learning university that you could use to train yourself, and also some of the blogs and video content you have online when it comes to machine learning. For businesses, we have the Machine Learning Solutions Lab. So if you want to kind of do some prototyping, do some high-level proof of concepts, we've helped a lot of customers do this as well. So we could work together with our Machine Solutions Lab to be able to help you apply machine learning to different use cases. And that's really all from us. Thank you so much for joining. And John, if you have any questions for us, that would be great. Happy to take them now. Thank you so much.
Thank you, Ozioma. Thank you, Emilia. Yes, we have some questions. Now, first of all, I'd like to experiment, says Abdul Azam. with ML and AI, but my maths is not very good. Are there any materials I can use to improve my maths for this?
So yeah, that's an interesting question, and I know a lot of people will be thinking the same as well. What sort of skills do I need? I think what we will be doing is to send a lot of content at the back of this webinar, so you get an introductory into machine learning in terms of the high-level maths you need if you kind of want to build the models themselves. But if you're a developer, you just want to kind of integrate machine learning into your application, check out some of our AI services to see how you can leverage them and integrate machine learning into your application. You mustn't be an expert in data science or mathematics to be able to start using machine learning or AI services we have on the platform.
And Rosaria asks, can we connect this to MATLAB?
Interesting. So what impact? It depends on what you want to connect to MATLAB and what you want to achieve from that. So if it's about kind of potentially hosting your data in S-Tray and kind of interacting with it from MATLAB, it's something to explore. In fact, MATLAB is also one of our partners, ISV partners, that you could actually deploy MATLAB on the AWS platform. And then we can work together if there is kind of a use case you're exploring of seeing how we can potentially allow you to maybe keep using your MATLAB, but maybe use data sources or data stores we have in AWS like S-Tray.
And Stuart was wondering if there's a maximum number of detections per second in the real world. He says, what are the governing constraints? For example, he has worked for companies making aerosol cans and things go wrong very quickly. Can SageMaker be used in very fast or very hazardous environments? And he wonders if you have examples, if it can.
Yeah, I can take this one. So when you have like this low latency requirement, you would need to train the model and have it deploy, we call it on the edge, which means the device as close as possible to your production line. So even on the camera itself, if you have compute power. And then like we would need to do some testing. What exactly is how many predictions per second you need? But it also depends on the stream you have, the camera capabilities, yeah, and compute power. And I guess that's the only constraints we would have. It will be deployed on the edge, so you would have the model running locally, not in the cloud, but can be controlled from the cloud for updates, etc. But still, it would need to be definitely the edge deployment example.
Now we have another question. What's the difference between supervised learning and unsupervised learning?
Interesting. So supervised learning is the machine learning when you are looking at data that is labeled. So for example, the data that Emilia showed us earlier, where you've got a marketing data that determines whether a customer kind of responded to that marketing activity, whether it's a yes or no, based on the information you have about the customer. So that's kind of a supervised learning. So you're using data that is labeled to train a model to be able to make predictions. What they are supervised, unsupervised learning is where you're using data that is unlabeled, that is not labeled. So think about some clustering use cases or things of that sort. So if you have data that is not labeled, is all what we call unsupervised or unsupervised learning.
Apart from SageMaker, what other AWS services can be used for hosting machine learning models?
Interesting. So we allow customers to host their models with other services on the platform. Like recently, we increased. I mean, we have a lot of services. Let's start with the infrastructure layer. So you can host your model on a plain old EC2 instance, our compute service, like our virtual machine, and expose those as an API for customers to query that. But we also have a lot of container services as well. So if you've packaged your model as a container, we've got things like Elastic Container Service and Elastic Kubernetes Service that you can potentially use to host your model as well if you don't want to do that on SageMaker. And recently we have increased the container image, or we recently enabled support for containers on AWS Lambda, and you can bring in images up to 10 gig into Lambda as a service, so you can also host your model in that way, and you get all the benefits of Lambda in terms of scalability and availability as well.
Yeah, just to add on that, if in this edge example, there is also Greengrass service, which we call, which you can also deploy the ML model on the Greengrass on the edge, closer to your factory line or workload.
Can Amazon recognition be trained using custom images?
Do you want to take that, Emilio?
Go, Ozzy.
Okay, cool. So definitely, yeah. So we have a feature called custom labeling on recognition, where you can actually label the images. So if you have an image where you kind of want to specify the particular item or particular thing within the image you want recognition to be able to recognize when you pass a new image, you can actually do that labeling within recognition. We call it custom labeling, and then train the model to be able to recognize those images if it sees it again, or if someone calls an API and pass an image with that with similar item in it. So it makes that provision for you to bring your own images. You wouldn't need to bring a lot of images as you would have done if you are building a brand new machine learning model. I think about 100 images or just over that. And we do to kind of train recognition to be able to recognize that, and then you can start querying the endpoint, the model endpoint with new images to make predictions.
Paul asks, as a private person, he wants to learn hands-on. Are there free services for learning purposes? And I think perhaps you can tell us about the links that we'll be sharing after this webinar.
I think it really depends on what you want to learn. And what we do is that as part of a new AWS account, you get what we call the free tier, where some services, you have a limit to using some services within 1 year of opening the account. So that's kind of a way potentially to get started. So we give customers a way to kind of trial and play around with the service within the free tier limit. So that can be a way to kind of start. But of course, if you want to do anything above that, and you are kind of maybe looking at that for your business or for your company, feel free to also kind of reach out to your AWS account manager or your territory manager. What we tend to do with customers is to also kind of run funded POC, where we will provide the AWS credit that will help you to kind of try out some of these services to see if it will be suitable for your use case.
Again, just to add on top of that, there is also the Educate path for students and graduates, where it will take you, actually it's like a training, or it will take you step by step for this path. And there are different paths, not only machine learning is one of them, there's also robotics, IoT, etc. But this is like a free program for students and graduates. So if that's the case, then you should definitely look into this.
Thank you. And another question, what algorithms is SageMaker Autopilot using behind the scenes to find the best performing model? Yeah, so there are a couple I know, but I'll definitely share links afterward as well. So one of them is the decision tree, the gradient boosting decision tree, and there is the neural networks as well, and the logistic regression. But like you would need to see exactly, once you run your model and you were able to open the notebook that doesn't generate it for you, you will see exactly what algorithms were used in the form of the Python scripts. I didn't have a chance to show that, as was not enough time, but
yeah, you will see exactly what your model used when you were using the autopilot.
Yeah, and just to add to that as well, I know usually the most popular ones that I used are XGBoost and Linear Learner. And then of course some of the things Emilia mentioned as well. So it's well suited for regression use cases or binary classification or multi-classification use cases, and yeah, usually applies XGBoost or Linear Learner, and then depending on the other use cases, you can apply other machine learning algorithms as well.
Thank you both. That brings us to the end of our questions and to the end of the session. Thank you very much indeed to our speakers, Emilia and Ozioma. You've given us a considerable insight into AI and machine learning on AWS, and you've really, I'm sure, given our audience some things to think about. We'll share the recording of this session in the next day or so. But before you close your browser, please do fill in the survey. It's very short, and we would really appreciate your feedback. And if you're in a rush, don't worry, the link will be shared in a feedback request email in an hour's time. I hope you've enjoyed this session and this series. Thank you to AWS, and thank you to our speakers today, Emilia and Ozioma. We will let you know about the next 4IT techELITE sessions as they are scheduled. In the meantime, thank you for attending, and goodbye.
Thank you. Thank you so much.
Thank you. Thank you.